Today we're going to start with a little experiment that I designed. It's 3 types of battery cables in 4 types of chemicals. We have salt water, gasoline, ATF, and brake fluid. All the cable used in this video is brand new. These jars are brand new, the liquids are brand new, everything's, legitimate. Nobody's paying me for this. The garage that this is being kept in is approximately 95 degrees Fahrenheit average. So the goal of the experiment is to give you, the viewer, all the data in an unbiased way. Let's talk about how it's set up. So in the salt water, all the cable ends are stripped and pointing down. This to hopefully promote wicking and corrosion up the cable. All the other jars just have the insulation submerged so that we can see the effects on the insulation, and we're not too worried about what the effects on the actual metals will be. And I want to back up 1 second. For the keen observers, they may notice that in the welding cable pile and the tinned marine cable pile, there's actually 2 cables that are switched. No worries, I caught this early on and switched them back when I put them in the jars. So all the data is good. It was just a mistake for this specific shot. Before we jump into this graph, I think it's a good time to stop and define the attributes of battery cables. The 3 things to consider right away are the conductor type, the gauge of the cable, and the insulation. When we talk about the conductor type, we talk about the metal that it's made out of, copper or aluminum. The lowest line on the graph is CCA. It's way down there because it's made out of aluminum. CCA stands for copper clad aluminum. So it is aluminum with a thin copper coating. One of the easiest ways to determine if a cable is CCA is that it honestly doesn't weigh very much at all. As you can imagine, it's quite light compared to normal. The graph perfectly illustrates that CCA has approximately 30% less ampacity as copper. I'll give you my opinion on it quickly. It's complete garbage. It should never be used, it should be avoided at all costs, and serves no purpose in an automotive situation. What we did do is we just tested it anyways, just for fun, to be honest. Just to see what would happen. So let's do exactly that. Let's just go see how it performed. So as we can tell, already on day 1, we've got a problem. Gasoline has wreaked havoc on that PVC jacket. It's not looking good for CCA. Here we can see a color change in the brake fluid. CCA is already starting to turn orange. Let's take a closer look. Something strange about the end here. The insulation seems to have expanded quite a bit. Looks like the gasoline's pulling the dye right out of the PVC jacket. Let's see how the CCA is doing in brake fluid. Not great. Starting to turn orange, very dark yellow. Here we are at day 7. Things definitely have not improved. Darker color. An even darker color. The brake fluid's almost red. So first one we're going to cut open is a CCA that's been in salt water. Here we just take it out of the jar. Set it on some paper towels. Here you get a first look at a little bit of corrosion on the end already happening after day 7. Now we're going to take a look inside the insulation. It's hard to show on camera, but it was wet all the way through. It remained flexible. And here you can see a bunch of aluminum strands showing. Next up, we'll check that CCA gasoline sample. Kind of an odd note here, the jacket actually became a little harder than what you'd expect. You'd expect it to kind of soften up because of the gasoline. It actually became quite hard. Here we are, CCA and ATF, or transmission fluid. Let's get that sample out here so we can take a look at it. I noticed something's wrong with it right away. Notice how the center does not bend. It's super rigid. The outside's fairly normal, the inside extremely rigid. As I start bending it, I couldn't get the audio on camera, but it does start to crackle. The ATF did not penetrate the jacket though. So, I guess there's that. And finally we get to CCA and brake fluid. Take the sample out like always. Kind of clean off a little bit. And now this is kind of a cool result. Look, it's made it more translucent. Kind of interesting. It's also ruined the jacket on it. It's super soft. Like, sketchy soft. Coming back from our little detour, let's look at this list again. Conductor, gauge, insulation. So, as we talked about, Conductor already eliminated CCA, just because it's aluminum. Now we just have two Contenders left. Welding cable and tinned marine cable. They're both made out of copper. So let's move to the next attribute, gauge. So wire and cable is sized by gauge. I think we'll do another video that describes exactly how that is done. But the gauge is the diameter. So the bigger the diameter, the more amps. Or you can think of it as the more copper, the more heat. Same thing. The first thing you'll notice is that they're both copper. So pretty much they're identical. There's not a huge deviation between the two. Definitely nothing worth quibbling about. So that kind of seals the deal on gauge. They're both copper. They both flow about the same amount of amps per gauge. So next we got to move to insulation. I pose this question simply. Between the two remaining cable types, are they capable of dealing with an automotive environment as far as the insulation is concerned? I think for this next part, there's going to be a lot of people heartbroken over the results. Let's go check it out. And we start at the beginning again. Nothing really going on the first day. Day 7, things start to show up. Welding cables turning green. And marine cable in the brake fluid, slightly darker color brake fluid. First we have marine cable coming out of saltwater. And you guessed it, it looks basically exactly the same as when it went in. I mean, this is exactly what it's built for. So it just makes sense. Let's cut it open a little bit here. Just kind of see what's going on. Inside the jacket ends up being completely dry. It's kind of the entire point of this cable. Jacket is the same as when it was new, extremely hard to cut, hard to bend. As you can see, no change to the tinned copper. Protects against corrosion. And here we are with welding cable in saltwater. You can see the color change in the water. The end of the copper is slightly color changed, but nothing too wild. It's only been 7 days. Next, let's get that thing open. So inside the insulation, there's kind of like a cardboard layer. And the thing we find out from opening this is the cardboard is completely wet all the way through. So water has traveled up the cable. That's not a good look. Here we have marine cable in gasoline. And as you can imagine, essentially it's the same as when it went in. I mean, like I've said before, it's the entire purpose of this cable. Nothing inside except nice copper. Then we move on to welding cable in gasoline. The welding cable didn't fare as well. It's very squishy. Far too flexible now. It cuts super easy. Kind of like the CCA. The inside is soaking wet. This is not a good result for welding cable. Then next we have marine cable in ATF. And you guessed it, it doesn't make any difference. You cut it open, you find out the inside is dry, everything's still clean, no fluid was able to enter the jacket. Next we have welding cable in ATF. And again, didn't go so well for welding cable. See that fat bulge? That's super soft and squishy. Actually hard to cut because it's so squishy. The ATF did not get to the inside though. The cardboard's dry. And now we have marine cable and brake fluid. You notice the brake fluid's a little darker. And check this out. It's discolored the jacket. It's slightly softer than normal, a little more flexible. And it cuts a little bit easier. It still counts as a damaged insulation, but no fluid has penetrated the insulation. And lastly, we have a welding cable and brake fluid. And it's discolored a bit, kind of hard to see on camera, but the main thing is the insulation has become extremely flimsy. As you can see here, it almost twisted in a knot. You can actually feel the copper crunching when you bend it because the whole thing's so flexible now. We'll cut her open and we will find that it is dry on the inside. A little bit surprising for how compromised the insulation feels by hand. Let's start narrowing this down real quick here. Let's wrap this thing up. CCA lacks conductivity. Welding cable lacks insulation capability. But we haven't even talked about OEM cable. You have to remember that OEM cable is the line in the sand. Everything to the left is not good enough. Everything to the right is better. The cable that's designed to basically deal with anything you could throw at it. I mean, this is designed for ships. So, in a car, it's kind of on a holiday. This is why this is the only cable type that we use at pin 87. I do apologize for the long runtime of the video. I tried to make it as concise as possible. Don't forget to like, subscribe, and ring the bell. And we'll see you on the next one.